Okay, ladies and gentlemen, let's talk about the power of the discriminant. Now, the discriminant is part of the quadratic formula. Now, a quadratic equation is a variable with power of 2, and it is set equal to y or f of x. Now, the quadratic formula allows us to break up a quadratic equation. Now, to do that, I can plug all of these into the full-on quadratic formula. A is 1, B is 10, C is 16, and I could go from there. But the thing about it is I don't always need this entire thing to actually talk about or figure out what I need. Sometimes I only need part of this information. And the part of that information that I need entirely depends on what I'm looking for. The first thing that I can find is the discriminant. The discriminant is just this portion right here of the quadratic formula, b squared minus 4ac. And what's underneath here could be one of three things. It could either be a negative number, a 0, or a positive number. In our particular case, I have negative 10 plus or minus the square root of 100 minus, now 4 times 16 is going to be 64, all over 2. So negative 10 plus or minus the square root of 36 all over 2. In this case, it's a positive number. Now, that positive number allows me, because it's under a square root, to take the square root of 36, which is plus 6 or minus 6. So in this case, I have negative 10 plus 6 over 2, and I have negative 10 minus 6 over 2. In which case I get 4 over 2, which is 2, or I get negative 16 over 2, which is negative 8. And in this case, I have two solutions. Well, if my discriminant is a positive number, even if I don't care to find all of it, as soon as I know that the discriminant itself is a positive number, I know that I'm going to have two solutions. So in this case, they are two non-matching solutions. Now, in my particular case, I came up with 2 and 8. So these could be two real solutions, which could be either rational or irrational. Now, the difference between rational and irrational, rational is something like 2 or negative 8, etc. Irrational would be something like 3 square roots of 3, something that has a square root left in it. Now, on the other hand, what if I had a discriminant that was actually 0? So in the case of x squared plus 2x plus 1 equals y, I get negative 2 plus or minus the square root of 2 squared minus 4 times 1 all over 2 times 1. Well, in this case, 2 times 2 is 4. 4 minus 4 is 0. I get negative 2 plus or minus 0 over 2. Well, the interesting thing is that goes away, and the only remaining answer is negative 1. So there's only one solution. All right, one solution, also known as roots, one root. And if, on the other hand, this turned out to be negative, negative numbers means there would be no solution because you can't take the square root of a negative. Now, that's not entirely true, because if I get a negative under a square root, there is technically an answer for that. X squared plus 4, y equals x squared plus 4. That gives me 0 plus or minus the square root of 0 minus 4 times 1 times 4 all over 2 times 1, which would of course be the square root of negative 16, which is plus 4i and minus 4i. So in this case, I do get two solutions, but those are two solutions that are imaginary or complex. So in this case, I have two real solutions. Here I have one real solution. I have no real solution. But I could have a number of imaginary solutions. In this case, I have two imaginary solutions. So the discriminant tells me how many real solutions, none, one, or two. Now the way this works out in a graph is a little interesting, because if I have two real solutions, it crosses at 2 and at -8. 1, 2, 3, 4, 5, 6, 7, 8. We know it's going to cross here. We know it's going to cross here. We also can say that this is definitely going to cross at, or the vertex is going to be at -3. Now, how do we know the vertex is at -3? We'll get into that a little bit later. And because it's a positive number, the leading coefficient is positive, it opens up and looks just like this. On the other hand, this one only has one solution at -1, but it also opens up. So how do I have a parabola that only touches once and opens up? Well, it's going to look like this. In this case, I had x squared plus 4. It's positive up front, but it has no real solutions. So it's going to be somewhere above the graph. And so the discriminant tells us how many real solutions, which in turn tells us, do I have two non-matching solutions? Non-matching means 2 and -8. Non-matching, they don't match. Here I have two solutions. They just both happen to be -1. Because I could factor this problem right here into x plus 1 and x plus 1. So I have two perfectly good factors. They just happen to be exactly the same. So these would be two matching real solutions. And then over here I have no real solutions, but I would definitely have two complex or imaginary solutions. All right, so we will start there.